Good morning, everyone. My name is Jay, and I'm going to be the session chair for this morning. And we've got a great talk coming up. We have Tennessee Leeuwenburg, who's an experienced data scientist and a developer of the Scores open source project. And he's here to talk to us about lessons learned from developing that open source project. Please welcome Tennessee to the stage.
Yeah, thank you very much. People all morning have been kindly asking me if I'm ready to give my talk or not, and I have to say the answer is no, not really. And the reason for that is, I think I've got a good deck and a good content and lots of good information, but I've been struggling to find, what's the story? What's the narrative spine? You know, where's the kind of hero's journey? What's the 3-act structure or the 5-room encounter that we're going to build out of this? And the reality is that making an open source package isn't really like that. It's just a whole lot of stuff. And a lot of this talk is just a whole lot of stuff. And the reason I made this talk is that I've got 20 years of development experience working with Python, and it was hard. You know, with all that experience, it was pretty difficult to, find all the information and make all the choices and figure out how to put it together. And the story of what was involved was just dealing with a whole lot of stuff. So, the talk, sometimes I give funny talks. This isn't a particularly funny talk, at least, not deliberately. And we're just going to go through the journey of all of the things that you might need to tackle and deal with. And the slides are pretty dense. That's because I want there to be a good record and a good set of content and things people take photos of or pause the video on. I'll try to talk separately from what's on the slide. I'll attend to the general theme. I'll call out a few stories and a few points we went through. But if there's sort of a lot up there, or I'm not addressing all of the points, fire them up if we've got time for questions, or drop them in the chat. And the other reason I'm not ready is that I don't think that I'm really terribly much more qualified than huge numbers of people in this room, particularly. And it sort of slowly dawned on me that I'll be presenting my own sort of experience and the experience of my team in building and constructing this package to a room full of people who may well have known better than we did how to make those steps along the way. A lot of these lessons were learned the hard way as I went, and no doubt there are a few surprises remaining waiting for me too. So a few things that aren't covered. Number one, naming your package. If anyone's figured out how, please let me know. Legal advice, I'm not qualified. You'll need to find your own course through legal advice, like choosing a license. Ditto approval processes. Wherever you find yourself, you may find approval processes a part of your life. They're up to you, and I'm definitely going to not touch the choice of a text editor. I think it's always helpful to start with one thing to take away. If you're going to take away one thing, these are good places to start. I wish I had found them before I started. I did not find them before I started. I did find package manager thingos. I don't know what these are called. One of them is called Hatch, and it describes itself as an extensible Python project manager. That sounds helpful. And the other one claims to make it all easy, which made me skeptical. But it is a commonly adopted framework, and both of these things do a lot of things. See also many blog posts discussing which one is better, which one is not better, why you should adopt one, when it's new, when it's deprecated. And yeah, there's a lot of complexity. We chose Hatch in the end, but we're really using only a tiny part of Hatch, largely because all of the various sort of decisions it's made, we wanted to be more kind of mindful of. So if I'm talking about me, I'm talking about me. If I'm talking about we, I mean the developers of Scores and the people who've made contributions. I may find myself falling into either sort of pattern at various points along the time. So both of these have, more or less to do with a bunch of the rigging and infrastructure and processes that are involved in, the activity of software development, explaining it to the internet, testing it, assuring it, going through release processes, all those sorts of things. But there are also choose-your-own-adventure versions of every single part of these as well. And sometimes those choose-your-own-adventure versions might be better documented or even a better choice for you. Okay, so how to lay things out on disk. This is one of those things that's changed. and become more mature, but there are some undocumented weirdnesses to how to lay things out on disk that I don't see talked about as much. At least I didn't come across them. So TLDR, definitely put your source code in a source folder and don't rely on the class path for finding your modules. Do use an editable install and a virtual environment for doing your software development. Okay, so here's how I lay things out on disk. And you know, this may seem like a dry topic. Like I said, building an open source package is just a whole lot of stuff. You'll notice there are some files sitting at the top level that kind of look like documentation, and there's a documentation folder. That's largely because various other parts of the ecosystem just expect things to be in particular places. And quite a lot of what we found out the hard way was like what things just have to be in some particular place or another for it to be found by, for example, GitHub or Google or the CI/CD package or various types of integrations. So the integration ecosystem around open source packages has got a bit harder. So I'm pretty happy. So each time we kind of go through one of these things, I'll comment on whether like we're happy with our choices. In terms of whether this is going to apply to every package, like probably not. But I think this is a reasonably sound starting point. Okay, configuration files. TLDR do use pyproject.toml. So more and more projects are using like pyproject.toml. I think this is great. Please do more of it. This was one of those we went one way, then the other way, then the other way, then the other way type scenarios for us. Like a lot of packages use dot files. I come from a generation that used setup.py by default, so I kind of started there before moving over to pyproject.toml. So there were some journeys sort of backwards and forwards. Like I didn't realize you don't need setup.py anymore. That was a discovery. You don't need setup.py anymore, and it seems to be better without it. So I will comment that like with the dot file type configuration, like your .pylint RC and .this RC and .the other RC and .CI/CD subfolders full of stuff that tells your CI/CD what to do, I feel like that's just hiding stuff, and it's like a contradiction. Like it's in your package, but you want to hide it so it's not cluttering things and being distracting. But your developers need to know it's there because it's how it all actually works. So I feel like that's something I feel like isn't maybe sort of solved perfectly yet. Versioning. Oh boy, did I get this one wrong. So I thought versioning was just, it was just kind of chill, particularly in the early days of starting a package. I thought it was just all cool. So I kind of, I made the numbers go, like, generally speaking up, but I oscillated on whether to put a V in front of the version numbers for a little while, and I started with a V, and then I pulled off the V. And that confused the heck out of the internet. That was really not a good call. And I also didn't think it like mattered whether you had the like, I just went with like 0.1, 0.2, 0.3, 0.4. I didn't realize you needed the patch part of the version number to kind of comply. But you really need that third one. And I think it played into a bunch of things in our early experience, like search engines didn't find us or our updates for a really long time, and it was incredibly confusing to understand why. So even at the outset, it was pretty important to use a really recognized convention for this, and well, I didn't realize. And the ecosystem plays really well with semantic versioning. It plays much less well with calver, and it plays medium-ish with a new one called fver, and it doesn't play very well at all with just whatever someone felt like that morning. You have to be fairly specific about it. So yeah, that was a surprisingly important thing. We went to version 1. We sort of tossed up that change. Like there's a lot of articles about what going to version 1 means. It seems to mean a lot of different things to a lot of different people. Python packages seem to like cruise on like low version numbers to quite a high level of maturity for a while. It's not amazingly clear to me why. We just went for it. So we did go for it when it was ready. So when I say we just went for it, we didn't just go for it. We carefully approached it and then mindfully decided to do it. But we didn't fear it. And I think that was a good call. Really, at the crux of the Semver system is information about what what's a fix and what's a bug and what breaks things backwards. And that's kind of what the integration needs to know. And it is better to provide that information if you can, and it hasn't been a problem. Right, branching. There are a lot of different branching strategies out there. Yeah, this is something where like there's a trade-off. Okay, so like what we do is we have tags for each release. It's pretty standard. We put our development on develop, not on main, which is like semi-standard. We merge to main just before creating each release, kind of semi-standard. But it means like there's this kind of contention between like when you go to GitHub, you see the default branch, which is our development branch, but when you go to read the docs, you see the latest release. And so they could be different. And I'm not really happy that they're different. And there doesn't seem to be a way to resolve that. So this was also something we changed partway through our branching strategy, like which one was develop and which one was main. The change didn't make many big problems, but it's probably better to be stable up front, because I think it did result again in compounding that like searchability of the documentation site issue that I referred to before. So it confused the bots until the documentation was configured really nicely, and it got happy when we did the tagged releases. It got happier when we went past version 1. It was like the search engines were less happy pre-version 1, and then once we started using sort of semver properly, then it started to understand how the versions of our documentation site like hung together and direct people to the right one and things like that. So there was sort of these unexpected links between things like branching strategy and whether when we told someone about our package they could find it. So there were these sort of like connections at a distance that you know, as far as I knew, weren't written down anyway. Automated testing, it's 100% totally worth it. It was worth it for us. I'm pretty sure it's going to be worth it for you. I really think this is important. There are still a lot of packages that don't have 100% test coverage. There are like really major Python packages where you go to their GitHub and it's like 84% coverage tests failing. And you know, these things are like running the world. And you just think, really? And if you're a new package and you're trying to like, you know, establish some credibility and trust, those badges and those status indicators, you know, they matter. They make a big difference to whether people take a look at what you've got and go, yeah, I'll happily use it, or whether they go, I might just wait. So I think it's important for that trust in the package. It's also really important for agility. Like if a dependency has a security issue because it's, you know, become outdated, you know, you can just like push go on that merge request very confidently, and you don't feel like things are going to break at all. And it's also been very helpful in making sure we support good library compatibility compliance. Like people might be aware, one of the major mathematical libraries recently went from like the exact versions don't matter. We'll call it 1.6 to 2.1. And just like tons of stuff on the internet broke. And it took like 3 months for all of the packages to go, oh, now we need to fix it. And that was because people didn't have, well, it was partly because of the semver thing where people were just using the latest package regardless of major version numbers, but it's also partly because the test cases weren't hitting it in all cases. So being able to just kind of confidently move forward, know that you're going to discover new issues during development rather than finding them on the release, it's just incredibly helpful if you're a package manager to have this in place. Some experiences with automated testing, troubleshooting, and a couple from beyond the scope of this, you know, our open source journey. So like a common one, performance tests are too slow to automate. People will often have like large realistic test data files they use to drive through their package to make sure everything's okay. That's fine. That doesn't need to prevent you from doing good 100% coverage. So that's a really important thing, and we've taken a number of the scores contributors through like how to do that, you know, how to go away from this kind of like large file on disk mentality to a separation of what the automated testing is covering and what else you also need to cover sort of separately. GUI code is hard to test. I just couldn't help throw that in there. That's more from my past life. Just don't put your application logic inside the click handler. Make it separate, make it callable. make the click handler call a callable function that's testable if at all possible. Make the memory and state model of the application shouldn't be the state of the GUI. Similar for command lines, except life's generally a little easier. Applications processing a lot of files on disk is pretty common in the sort of science space, where you've got carefully crafted, mathematical array-based inputs that match precisely various outputs. A lot of the sort of domain people, so in my case scientists, but in any case the domain people might be quite comfortable creating those test rigs as like files and file formats they know how to make, maybe in applications they're familiar with. It gets a little, and as a result, a lot of the functional part of your application can end up just going direct to disk and taking file names and passing file names around. And then when it comes time to test it, it's really hard. It's either slow because even with SSDs, disk is slower than memory, or it's really flaky because you've got to pass around strings and manage program state, manage the state of the variables in your automated tests, and you can't just get in there and interpose terribly easily. It starts getting a little bit gnarly. Moving to something which passes around file-like objects allows you to create data on the fly straight into memory without hitting the disk. It's much quicker, and it allows you to have a more modular design that's going to let you interpose on things. So this is one of the things, like a point like that is why I'm not ready. This is like my story. I don't know if I can give that advice to kind of everyone. What's exciting about that? Well, it mattered to me, and it mattered to creating this package so it's an example. Some random tips on testing. Hard to cover all of them, but work out how many decimal places to test to and do it consistently. Computers are both brilliant at maths and kind of bad at maths. If you do the wrong sort of order of operations or something changes, you are going to get different numbers down in the fine scale of those decimal places, and you will need to figure out if that matters to you. We figured out a number of decimal places and more or less standardized on it. It's a good idea. With the test data I was referring to previously, essentially we stored it inside .py files. That makes it pretty easily discoverable by the test rigs and the test fixtures. It means you can import your test data easily, and you don't have to sort of do a little bit of, used to be called reflection APIs, to discover what directory you happen to be sitting in at the moment and where your source code happens to be coming from and where you think your test files probably are in order to load them into memory. If you can just put it straight in a Py file, it's a bit more straightforward. And if your code is hard to test, it can indicate a problem with the code. Okay, type hinting was a journey. I'm not bitter at all. So this is a situation where I've got a pretty different opinion to the norm. So I want to both give you my opinion, but also explain to you that it is not the commonly held wisdom, so that both of those things are clear. Okay. So a lot of people really like type hints. And if you're well, I'm handling forms all day long, and I really, really need to know the difference between an integer and a string. That's fair. That's crucial to your application logic. I wanted to write really general code, and a lot of the functions, I could support an int, or a list of ints, or a Python array of ints, or a numpy of ints, or any kind of number really, or xarray object, or pandas, or any one of about 3 or 4 different pandas alternatives, and the major xarray alternative. And it would be kind of nice to support the backends for PyTorch and TensorFlow at the same time. And that's all reasonable for maths. So trying to type hint that is actually kind of pretty complicated. And one of those libraries, and I am not going to name them, you cannot inherit from. They have done funky metaprogramming, and you just you can't do it. And if you want to have an extension to their classes, you have to use their funky registration process to add your functionality into their classes. So type hinting was very difficult and not very helpful for these complex compound types where you're trying to write polymorphic code that can just handle whatever you throw at it, which I was happy to do. We were happy to do, we could easily handle it. But on the other hand, people wanted that sense of safety that comes from type hinting. And I've also seen this gradual move from type hints, which sounds kind of, free-flowing and relaxed, to type annotations, which sounds a little bit more formal and a little bit more expected. So I think, the world will thank you for providing type hinting and type annotations. It will thank you for providing that information on your APIs, which I think is fairly appropriate in terms of like return types and things like that. But at the same time, it's not necessarily informative, and it can be actively misleading when the code itself will comfortably support multiple different types which passed. But it's easiest to just conform. Linting and static analysis. There's a lot that's been said on linting and static analysis. This is kind of my take. Like, black is useful and fast, just use it. ISort is useful and fast, just use it. Rough is a recently developed tool, which is kind of really interesting. So it's very fast, and a lot of the time, like, fast tools are very comfortable to adopt because they fit very neatly direct into the editor experience. But it doesn't have enough kind of functional coverage for me at the moment compared to, like, PyLint or something that's going to check a few more things. And yeah, security static analysis, you'll have to do some reading on the security management as well. Documentation. We lent into documentation, and we lent in hard, and it was just well worth it. So here are the kinds of documentation that you might want to consider writing. We did all of these, and all of them have helped in their various ways. So docstrings and code comments, the major dispute that I hear on docstrings and code comments among people from different perspectives is that, well, the code does what the code does. It doesn't do what the comments or the docstrings say. I would generally argue that even an incorrect docstring or comment can be remarkably illustrative to the intent or hopes of the person that wrote the code, and that there is not really a source of truth about what should be happening in the code, regardless of what is happening in the code. And certainly people appreciate having a lot of good information, particularly around the API docs. Contributor guides have been mainly helpful for me as the package maintainer. Like, in theory, they're for everyone else, but actually, like, to a large degree, they're a reminder to me of what I ask people to do so that I can be reasonably consistent. Because left to my own devices, I'll be wildly inconsistent and confuse everybody. So it's been a helpful aid to memory for me to be able to work through things. And it means that if someone else needs to oversee a merge request process or pull request process for a period, it's fine. Websites, like technically you don't need one. You can just put your code out there on GitHub. You don't need to go to PyPI either. You can just make your code available. It won't be like, you won't get in trouble for not doing it, but it's obviously essential to discoverability. Consider examples, tutorials, and notebooks. I think there's a rant later in this talk about making your tutorials work, but just in case I forgot to include that slide, I'm going to do it twice. It's really important, at least to me, to make the tutorials actually work. I would estimate, like, straight up weeks, like, 8 hours per day times 5 days a week times some number of weeks on tutorials that just didn't work. Just like debugging someone's tutorial out there that is simply, like, non-functional. And maybe my success rate at, like, making the tutorial function is maybe like 25%. Like 75% of the time it's like, well, the source data is moved and is gone and requires a sign up, and all the versions of all of the things in this tutorial have changed, and I just, didn't get there. So yeah, again, not bitter at all. But our tutorials work. So, perfect testing, like, could they ever break for a short period of time until we fix it? Yes, it's possible, but we actively maintain them. So, feel free to go find a broken tutorial and prove me wrong, but we will fix it right back at you. Okay, so how to do docstrings. Give every function a docstring. The exceptions to this rule aren't worth arguing over, certainly not in a presentation. Comment liberally. Relating a few nebulously connected comments like docstrings, mathjacks, web pages, tutorials, and docstrings, like, they have helped me find bugs doing code reviews in other people's code often. So it is very important, because programmers, all of us, we're all just, flawed humans, and our expression in code is not necessarily perfect. And so expressing our ideas twice in two different forms fixes bugs, which is, I think, important. I don't think that's like the most important. Like the most important thing is that other developers can go back later and read it, or like you in 3 months, or if you have a short memory like me, like a couple of days later, it tells you what you were trying to do in the first place. That's very important. We've used Napoleon-style docstrings. I've no idea why they're called Napoleon-style docstrings. I assume Napoleon didn't invent them, but I haven't gone further. But it has been a reasonable choice, and we use it to drive the API docs, obviously. So the documentation tech stack, I only found this one, like this YouTube video, like this just fixed it for me. This was the answer. So thank you to whomever, and apologies, I don't know the pronunciation of the native language here, Juan Luis Cano Rodriguez. Thank you. This was what allowed us to string together the technologies that we wanted to work with. Sphinx can go the distance on the functionality you want in constructing the web page. Markdown, at least among this particular development team, was universally more pleasing to write documentation in. And this particular tech stack allows us to stitch all the tools together. It was a great choice. Right, the source code for documentation. Okay, this is kind of like the problem you don't want to have, but it's going to be there. The documentation is like this little world of its own, and it looks so innocent. How Markdown files can have so much complexity is remarkable. They will render differently everywhere, and it's a challenge, and it's a thing. And there are rules that I've tried to document that I can't even express in English. I just like remember that magically that part of that style of Markdown in that kind of API string in that kind of way, I have to do this slightly differently. And I've just never been able to explain all the details. So we've tried to achieve consistency between, and I'll just go through the list. PyPI, GitHub front page, GitHub viewing the documentation folder, GitHub looking at the tutorial folder, because the README goes onto PyPI, local builds of the documentation, people actually running actual Jupyter Lab for our tutorials as opposed to the documentation rendered version of the tutorials, read the docs versions of all of the things that I just mentioned, and Binder and NB Viewer. So that's like 10 different like rendering contexts, plus actually reading the Markdown files. We had to make some compromises. Some things were just not possible to support. The greatest thing we ever did was make this 228 branch where we can just push stuff and everyone remembers what the URL is. And if someone says, hey, my pull request is good to go, can you show it to me? We just force push it to 228. It renders and read the docs on a hidden link and we go, check it out. And that's been incredibly helpful because not everyone's... It's not actually hard to build the documentation. Like that bit is really quite straightforward, but a lot of people feel more comfortable when they see it for realsies on the internet. The good news is that everybody really, really appreciates good documentation. If part of your motivation is to get adopted, like do good documentation. It's going to make probably a bigger difference than anything else. People will happily have half as much functionality and twice as much documentation and something reliable. I feel like narratively I've covered a lot of this already, but I think it's very much helped with onboarding people. And if you have a particular domain or field that you're working in, it can also help people from the domain perspective on board into their side of the process as well. And I really like looking at MathJax. Okay, ecosystem. The rules are not obvious, and this was the biggest thing where like no amount of like internet search could answer these questions for me. It just experience only taught me these things. Possibly I'm wrong, possibly I was naive at the outset, but these were the things I discovered. So Semver, you basically have to do it. Release notes, that's totally free form. You can do anything you want with your release notes within reason. The process, like how to publish to PyPI, like discovering the one recommended path was very difficult because there are very, very many paths that are referred to online. And a lot of those guides are outdated, and I had a really hard time figuring out. Our process is straightforward. I have 1 minute to go. We tag the releases, use compatible versions. They're much better than greater than or equal to. How and what to automate. We didn't automate anything. We retained manual control of the final version publishing to places. That was a good call. basically everything else is automated, lean into automation. Community considerations, and I've just been given the 1-minute flag, so this should be, like, there are and should be many talks on community considerations. The main thing that we kind of did up front was make sure to have a good code of conduct and make sure the contributor covenant is now widely adopted and well respected. So in the past it was much less clear how to do this in a way that's going to work for everyone. Now it's pretty good. Okay, we published a paper in the Journal of Open Source Software. In some disciplines, academic citations are really how people are going to be able to get recognition for their work, and it's very important. So if you do publish your own package, consider an academic publication, such as in the Journal of Open Source Software. It's a great way to support your colleagues if you're working in an environment where you want to get the scientists on board with your work. And we are one slide away, but I'd like to thank all of the contributors to our open source packages for a moment, just to appreciate all of their work. In conclusion, it was a worthwhile experience, and I hope perhaps that this may be able to help someone else avoid some of the pain that we experienced along the way. Thank you.
Thank you very much, Tennessee, for that awesome talk. We've got a small gift of our appreciation, this great Pycon mug. We're not going to have any time for questions right now, but I'm sure Tennessee is happy to chat throughout the rest of the conference. We're going to have a small pause just for people to move around, but the next talk in this room is going to be Simon Aubrey talking to us about DuckDB. So thank you. Let's thank Tennessee once more.